This video is on lens effectivity. It's the third video of my Optics of the Human Eye series, and in this video I'll show you how to convert a contact lens prescription to an eyeglass prescription and vice versa. So lens effectivity is extremely important in clinic. You cannot be an optometrist and not know lens effectivity. So let's start off with this picture, this figure in my textbook. So let's say someone's wearing a contact lens prescription. So this is a representation of a lens on the eye. So let's say the person is wearing a minus 6.68 diopter lens. So you cannot use this prescription as the person's eyeglass prescription. That's because the glasses sits in front of the eye while the contact is directly on the eye. So in this case, you can see that the eyeglass prescription is actually minus 7.42 because the eyeglasses usually sit about 15 millimeters or 1.5 centimeters in front of the eye. So there's a way where you convert the contact lens prescription to the glasses prescription and vice versa, and this is called lens effectivity. So let's start off with the eyeglass prescription, because in clinic you will always have the eyeglass prescription first, then you convert that to the contact lens prescription. So to find out the contact lens prescription from the eyeglass prescription, you first do is you take 1 and you divide by the eyeglass prescription. So in this case is 1 divided by minus 7.42 diopters. The 1 comes from the index refraction of air. And then you plug this into your calculator and you will get minus 0.1, let me just move this, 0.1347 meters. It's the same thing as minus 13.47 centimeters. So that's the far point of the eye. So the 13.4 centimeters is the distance between the eyeglasses over here to the far point over here. The negative sign indicates that the distance is to the left. Right? So it means that the far point is to the left of the glasses. If this was positive, then the far point would be to the right of the glasses. So once you have this distance, you need to find this distance from the far point to the eye, because you're trying to find out the contact lens prescription. So you want to find out the distance between the far point to the eye. So that's very simple. Just add this plus this. Right? So the answer would be minus 14.97 centimeters, which is the total distance between the far point to the eye. So once you have this distance, you take the inverse of this distance to find out the prescription of the contact. So what you do is you take 1 divided by 0.1497 meters. Again, that's negative. And you plug this into your calculator, you get minus 6.68 diopters, which is your power of the contact, right? Which is you have over here. minus 6.68 diopters. Right. So I recommend you drawing a picture, and once you draw a picture, everything becomes a lot easier. So now let's go to a positive lens. So let's say that the patient is wearing a positive 2.82 diopters. So you do 1 over 2.82, and you get positive 0.3546 meters. And because it's positive, then the fall point is to the right of the lens. So here you have 35.46 centimeters, which is the same thing as 0.3546 meters. So that's the distance between the contact and the fall point. Now, what's the person's eyeglass prescription? Since the glasses sits in front of the eye over here, now you have to subtract the distance, right? Oh, excuse me. You're going from your contacts to the glasses in this case, so you have to add. You're starting over here first, and then you're going to here. So you have to add this distance. So you're starting over here first, right? And then you're going to this here, so you have to add. So 35.46 plus 1.5 gives you 36.96 centimeters, which is the distance between the far point of the eye all the way to the eyeglasses over here. So you do inverse of this. You do 1 divided by 0.3696 meters, and then you get plus 2.71 diopters, which is this over here. So you might notice that the contact lens prescription, 2.82, and the eyeglass prescription, 2.71, there's not much of a difference, and you're right. Because this number is less than 4, the difference between the contact and the eyeglasses is very minimal and is not clinically significant. So if this number is less than 4, then the contact lens prescription, it's basically clinically the same as the eyeglass prescription. For the first example I did, the contact lens prescription here is more than 4, more than minus 4. And because of that, the eyeglass prescription is much more different than the contact lens prescription, so it's clinically significant. So in clinic, we don't go through all the calculations. We have a chart that we use called a vertex conversion chart. Vertex conversion chart. So the middle number is the person's eyeglass prescription, and the left side over here is converting from a minus prescription, minus eyeglass prescription, to a minus contact lens prescription. Over here is when you have a positive eyeglass prescription converting to a positive contact lens prescription. So as you can see, it only starts up with 4 because if it's less than 4, then it's not clinically significant. The eyeglass prescription is the same as the contact lens prescription. So here's your eyeglass prescription. Let's say you do refraction and you get a minus 5. Then the contact lens prescription is a minus 4.75. If you do refraction, you get a positive 5, a plus 5, then the contact lens prescription is a plus 5.25. Right? It's less, minus, more, plus. Always less, minus, more, plus. Now, as you go higher and higher in the eyeglass prescription, there's more and more of a change. So in this case, it's only changed by a quarter. But in this case, if you go to 20 diopter refraction, there's a change in 6.37 for plus and about 4 for minus. So the higher you get, the more the difference between the glasses prescription and the contact lens prescription. That's why below 4, the change is so small that it's basically the same. Okay, hopefully that helps. Here,